Welcome to Electronic Devices and Instrumentation Laboratory. Subject code is 18ECL37. Myself, Prabha K, working as Assistant Professor in the Department of Electronics and Communication Engineering, Sai Vidya Institute of Technology, Bengaluru. Today, we will discuss about negative clamping circuits. The aim of this experiment is to design and verify negative clamping circuits for a clamping level of plus 3 volts and minus 3 volts for 1 kHz sinusoidal input signal having 10 volts peak-to-peak voltage. Components required are diode IN4007 and a capacitor of 0.47 microfarad. Clamping circuits are used to add DC level or a DC component to the AC output signal as per the pre-requirement. In this, a negative DC voltage will be added to the input signal. That's why the output we call it as negative clamped output. The circuit consists of capacitor and a switching diode. The value of capacitor should be selected as per the time constant RC such that it will be large enough to ensure that the voltage across the capacitor does not discharge significantly during the interval when the diode is in non-conducting state. These are the negative clamping circuits. First one gives you a clamping level of plus 3 volts and the second one is designed to get a clamping level of minus 3 volts. Both the circuits consist of 0.47 microfarad capacitor and a diode with a power supply and a signal generator to give the sinusoidal signal as an input to the circuit. This is negative clamping circuit designed for a clamping level of plus 3 volts. Here we are using a capacitor of 0.47 which is connected in this fashion, and this is a diode. Here the circuit consists of a capacitor and a diode. The diode is connected in such a fashion. The signal from the signal generator is given to the circuit. The positive is connected to the one end of the capacitor. To the another end of the capacitor we have connected anode of the diode. To the negative of the diode, that is a cathode of the diode, we are connecting a power supply positive terminal, and the remaining terminals, that is one from the power supply, the negative terminal from the power supply and the negative terminal from the signal generator is connected to the common point. The output is obtained between point cathode of circuit, that is a ground point, and the anode terminal of the diode. So connect CRO probe positive to the anode of the diode and negative to the common point. This is the input signal. Apply DC voltage which is set for 2.4 volts as per the design. And observe the output in DC mode. We can make out there is a shift in the waveform towards the negative voltage. The positive peak of the waveform is at plus 3 volts. This is the output of negative clamping circuit where the clamping level is set for plus 3 volts. Both input and output can be observed simultaneously. Connect another channel to the input side with the help of a probe. Put the CRO in the dual mode. You can make out there are two waveforms One is the input, another is the output. You can make out that the output is clamped or shifted towards negative side. This is output. This is both input and output. This is a circuit diagram for a negative clamping circuit with a clamping level of -3 volts. It consists of 0.47 microfarad capacitor with a diode and a power supply and the signal generator. This is a circuit of negative clamping and consists of a capacitor, a diode which is connected such a way that this is anode and this is cathode. Signal is given here from the signal generator, positive terminal here, negative to the common point. And power supply is given from the DC RPS. The negative is connected to the cathode of the diode and positive terminal is connected to the common point. Set DC power supply for 3.6 volts as per the design. This is the input. To check the input and output together, put this arrow into the dual mode. You can make out both input and output. This waveform is input and output is clamped towards a negative side. You can make out apply the voltage. Very clear that the waveform is clamped towards negative side with a clamping level of -3 volts. That means the positive peak of output waveform is set at or is appearing at -3 volts. So, 3 divisions, small divisions, 1, 2, 3. 3 small divisions into 5 volts. So each division represents 0.2, 0.2. So 3 division means 0.6. 0.6 into 5 is 3 volts.